Good morning. Today, lesson 4.2, we're going to be talking about using intercepts of a function to graph that function. So our objectives today are to find the x and y intercepts and interpret their meanings based on the variables that we are talking about the relation for. And we're going to use x and y intercepts to graph lines. Take a quick second to write down x-intercept, y-intercept. That's our main topic for the day, the two intercepts, and what they mean. The y-intercept, if you think about what we're talking about, the y-axis, is the point of interception where our line, in this case the red line, comparing elevation to time, we're taking this red line and intercepting the y-axis. This is referred to as our y-intercept. You can see we're down in the fourth quadrant here. X is positive, y is negative, so we're down in the fourth quadrant. We're also talking about x-intercepts, and we can see, again, that point at which the line passes through the x-axis. Finding intercepts by looking at a graph is just as simple as it sounds. We're going to locate that point on the y-axis. We're at positive 1, negative 2 on the x-axis, and we simply write y-axis 0, 1. X is always 0 on the y-axis. The y-intercept is 1. We can write y equals 1. And we noticed that the x-intercept is negative 2, 0. The x-intercept is negative 2. Two different ways to write that. Now we're going to be looking at the function, not the graph. This involves just two more steps. We're going to find the x and y intercepts. We just realized by looking at the graph that if we're talking about the x-intercept, y is 0. So we replace y with 0 in our function and solve for x. That looks like this. Taking the y out, replacing it with 0, eliminates the term altogether, and we see 5x equals 10. Therefore, x equals 2. X equals 2 is the y-intercept. We're going to do x-intercept. We're going to find the y-intercept now, and we realize from the graph that when we're on the y-axis, x is 0. If x is 0, the term cancels, disappears, and we get negative 2y equals 10. Dividing both sides by negative 2, the y-intercept, negative 5. In order to graph that quickly, we're simply going to go to the x-axis and graph our intercept, go to the y-axis, and connect the points. Check it out. Number 1, you guys do this one. Come back with your solutions. So we look at the y-axis to find the y-intercept first, and we locate that point 1, 2, 3 units above the origin. Our y-intercept would be positive 3 or 0, 3 as an ordered pair. Our x-intercept would be negative 1, negative 2. Negative 2 for our x-intercept. Negative 2, 0. We can write them as an ordered pair, or we can state y-intercept is, x-intercept is. Now you're going to try it, your hand, at locating the intercepts with the equation. Remember, we're going to find the x-intercept by replacing y with 0 and then solving. Negative 3x equals 30, so x equals negative 10, our x-intercept. Doing the same steps, except for our y-intercept now, we're letting x equaling 0, solving for y, 5y equals 30, so y is equal to 6. Two intercepts, x is negative 10, y is positive 6. You guys try, check it out, 1C, come back and compare your answers. So we allow x and y to equal 0. First, let's let y, 4x equals 16. When y disappears, the y term, so we solve and x equals 4. We're going to let x equals 0 to solve for the y-intercept. 2y equals 16. Dividing by 2, y equals 8. So let's apply this to a real world situation. It says Trish can run the 200-meter dash in 25 seconds. Bill, is that a good time? 200 meters, 25 seconds? She's Trish. A girl. Pretty good. Okay, Bill says that's pretty good. The function f of x equals 200 minus 8x gives the distance remaining to be run after x seconds. We have a total of 200 meters. She's running 8 meters per second. Graph the function, find the intercepts, and what does each intercept represent? Neither time nor distance can be negative, so we choose several non-negative values for x. Use the function to generate ordered pairs. At time 0, she's still 200 meters from the end line. After 5 seconds, we've multiplied that by 8. We've subtracted 40 to get 160 meters, etc. We want to talk about these 2 points, 0, 200, and 25, 0. What do they mean? We're going to graph the ordered pairs, connect the points with a line because it is a continuous graph. She doesn't leave any distances behind. She covers them all. The y-intercept, 200. This is the number of meters she has left to run at the start of the race. So as the race goes on, 3, 6, 9, 12 seconds, she has fewer and fewer meters to the finish line. The x-intercept, 25, is the time it takes her to finish the race, or when the distance remaining is 0. You guys try this one and see what you come up with. It says the school sells pens for $2 and notebooks for $3. Our equation, 2x plus 3y equals 60, describes the number of pens and notebooks that you can buy for $60. Graph the function and find the intercepts. Once again, we have to stop and think, do negative pens or notebooks make any sense? No. So we choose only positive value for x. X is the number of pens. Y would be the number of notebooks. And we're going to choose positive values. What do these two intercepts mean? When x is 0 and our function is 20, or when x is 30 and our function is 0. Well, we look at our graph. Is that your knee? We look at our graph and see when x is 0, notebooks is 20, meaning we can buy 0 pens and buy 20 notebooks, or we can buy 0 notebooks and 30 pens. Remember, to graph a linear function, you need to plot only 2 ordered pairs. That's why we're dealing with intercepts right now. It's often simplest to find the ordered pairs that contain the intercepts. You can use a third point to check your line. Either choose a point from your graph and check it in the equation, or use the equation to generate a point and check that it's on your graph. Let's graph this equation by finding the intercepts. We're going to find the x-intercept by allowing y to equal 0. You can follow along with that algebra. We see that x equals 7 when y is 0. And we can find the y-intercept the same way. We're going to allow x to equal 0. And we see that our y-intercept would be negative 3. Use these 2 points. We found 7, 0 and 0, negative 3. Simply plot them on the coordinate plane and connect. Let's try this one. Write the equation in standard form. Remember, ax plus by equals c. Adding x to both sides, we get an equation in standard form, which makes life much simpler. Finding the intercepts, we allow x to equal 0 and y to equal 0. In the second instance, x is 4, and our y-intercept, y is 4. We plot those 2 points and connect. You guys try this one and check it out in a second. Once again, using intercepts to graph the line, we're going to put it in standard form. Well, it already is. We're going to find the x-intercept by allowing y to be 0. We're going to do the same thing. We're going to allow x to equal 0 and solve for y. 2 intercepts. We plot the points and connect with a straight line. Let's try this one. Again, they want us to put this in standard form. Multiplying both sides by 3 clears our fraction. That makes it easier. 3 on the left side gives us 3y. 3 on the right side gives us 1x minus 6. And we're going to subtract x from both sides, allowing y to equal 0, negative x equals negative 6. Therefore, positive x is equal to positive 6. Same thing for the y-intercept, allowing x to equal 0. We solve and get y equals negative 2. Plotting the points, connecting with a straight line. Graphing has never been this easy. I want you to answer this question and come back and check the answer. So we're given the function y equals 6,000 minus 75x, $75 per hour. That's a cost going out. He has or she has $6,000 to start with. Every hour they spend filming, they are spending $75. It says, let's find the y and x intercept. We know that if we allow x to equal 0, y is 6,000. We've subtracted nothing. But when y is 0, 75 times what is 6,000? We determine that to be 80. Number of hours it takes to spend all of the money. Check out your lesson on PowerSchool 442, and we'll see you tomorrow.